So in this lecture what I will be doing is I will be solving numericals related to KVL, that is Kirchhoff's voltage law. Then I will solve some numericals related to KCL, that is Kirchhoff's current law. And also I will solve some numericals related to the Ohm's law. So starting with, so all these numericals are being formulated by me myself, so you can do the solutions, and if there are some errors you can also let me know, but I'll be solving them and trying to validate the correctness of each of the problems. So simply the first thing, so in the last lecture what we saw was about the Ohm's law, and the previous lecture before that, so the resistance, it can be given by V by I, and the unit of resistance is ohms. So one of the simplest way to remember this is having a triangular form where you can write it in like VIR. So V is always equal to IR, and I is always equal to V by R. So these are the basic equations. So coming to a simple circuit where you can use this. So I'm having a circuit which I'm drawing right now here, and if you consider the resistance of this is 20 ohm, and I'm connecting this to a battery. So this is a symbol of the battery, and the battery is 100 volt. So now the question is to find the current. So this is my problem 1, and the question is to find the current in the circuit. So to find the current in the circuit is equal to V by R. So from the Ohm's law, so we are applying the Ohm's law, and simply to find the current is 100 divided by 20 ohms. So this is equal to 4 or 5 amperes is the current in the circuit. So this is one simple case where we have applied the Ohm's law. And going to another circuit, if you have one more circuit, there's 3 resistance, 10 ohm, 10 ohm and 10 ohm, and it's connected to a voltage that is 100 volt, and again you have to find the current. Now this 3 resistance and it are, you can say it is R1, R2 and R3. So again you have to apply the series equation, so the equivalent resistance. So this is a second problem, and again the question is to find the current. So the equivalent resistance in the series case will be the summation of all the resistance, and it will become R1 plus R2 plus R3, and the equivalent resistance can be known as 10 plus 10 plus 10 equal to 30 ohm. So the current in the circuit will be equal to the voltage divided by the R equivalent. Again this will be equal to, the voltage is 100 and the R equivalent is 30, so it will be 100 divided by 30. So current will be 10 divided by 30, which will become something like 3.3 amperes. So this was again a second equation in which I applied the Ohm's law, and there is R equal to V by I. So this is a very simple problem. So there could be another questions which could come like the current could be given as 10 ampere, the voltage could be given as 100 volt, and the equation is to find the resistance in the circuit. So the resistance is equal to V by I. So this is the third problem which you are solving, and equal to 100 divided by 10. So the resistance is 10 ohm. So this is the third problem of simple solution. So again there is one more problem. So there's we are going to use a VIR, and that is R is equal to V by I, which is Ohm's law. So this is a simple circuit which we are having. So this circuit is an electrical heater, and what you have to find, the resistance of this circuit is 200 ohm, and the voltage is 100 volt DC, and you have to find the current I. What you find is, this is a fourth problem, and this is you have to find the current I in this case. Also you have to find the conductance of the circuit. You have to also find the power consumed by the circuit, P. So the equation of P is equal to VI, or it can be also found out by I square R. So this is a mathematical way to define power for the electrical DC circuit consisting of only resistance, and the equation of inductance is equal to 1 by R. So simply to find out the current can be found out, I is equal to 100 divided by 200. So again the current comes close to 0.5 ampere, and the power consumed by the circuit is 0.5 whole square, that is I square, into R, which is 200. So this is equal to 0.25 into 200. So this is equal to 0.500 into 100, which is equal to 50 watts. So unit of power is watts, and this is equal to 50 watts. So this is again application of Ohm's law and the equation of the power in a circuit, which is given by I square R. So this kind of problems can be easily solved. So now what I will be doing is, I will be using the KVL and the KCL. So I am having a circuit which can be written in this way, which is made up of resistance. The electrical circuit is, this is my current I, which is flowing from the battery, which is 100 volt, and this is my resistance R1, this is my resistance R2, and this is my resistance R3. This is 10 ohm, again this is 20 ohm, and this is 20 ohm. So the current, it is seen that the current I will have two paths after it is coming here, and this current is I1 and I2. So the KCL, it says that the current I at any node, this is a node, will be such that it will the current entering the node will be equal to the current leaving. So the I1 will be always equal to I1 plus I2, and the KCL, what it says is that, so the voltage across this resistance will be VR1, and this will be VR3, and this will be VR2, and the voltage will always, the drop will always from the positive side to the negative side, and it will be from the positive side to the negative side, and it will be from the positive side to the negative side. So while applying the KVL to the loop, what you will find is that when you are going, you will have two loops in this case, or two closed paths. So one pathway to go through the circuit is this way, and the other way is this way. So you will apply KVL to both the paths. The first path, first thing is considering this is a rise in voltage. So whenever you are having rise in voltage, you are considering it as a negative, and there is a drop in voltage, so you are considering it as positive. So VR1 is plus VR3 equal to 0. So this is the first equation, and the second equation is, in the second loop if you are going, then minus 100 plus VR1 plus VR2 equal to 0. So this is the second equation. So you have applied the KVL and the KCL in this case. So simply what you find is that to find the current there is multiple ways, and first you need to find the current I. So I will redraw the circuit. So this is 10 ohm, this was 20 ohm, and this was 20 ohm, and this was 100 volt. So my aim is to find the current I. So this is I1, this is I2. So my VR1, in any case I can write it as I into R1, and my VR2, this is a resistance R1, this is a resistance R2, and this is a resistance R3. So VR2 I can write as I1 into R2, and VR3 I can write as I2 into R3. So again I can write I equal to I1 plus I2. So this is what I'm doing, and so while solving this full problem, again what you got by applying the KCL was minus 100 plus V I R1 plus I1 R1 equal to 0. And minus 100 plus I R1 plus I2 R2 equal to 0. So these are the equations which you are having. So there is one way to solve this problem, would be like you can solve this series parallel circuit, and you can find the value of I, and after that it would be easy to find the VR1, and you can easily solve that. So that will be one of the simple way to do that. Otherwise you can use all these equations and you can put some form of substitution. But you are having one equation here, you are having two equation here, you have three equation, this is your fourth equation, you have five equation. So you can make use of these equations and you can solve the circuit. Or the other way could be like you could be solving the circuit using series parallel method. So again, the finding the R equivalent resistance of the whole circuit is 10, and when I'm doing this in a parallel, this will be 20 into 20 divided by 20 plus 20. So what I will getting by R equivalent, it will be like 10 plus, this will be my 400 divided by 40. So this will be like 10. So this the total circuit would be like 20 ohm will be my equivalent resistance. So I got my equivalent resistance of R equivalent equal to 20 ohm. So my current I will be equal to like 100 divided by 20, which will be equal to 5 ampere. So I got my I. So from this case it's simple to find my VR1, which will be equal to 5 into 10, which is equal to 500 volt. And again, it's simple to find that this current will, since it's a parallel circuit, this current will divide in this both in equal form. So this will be 2.5 divided by here and 2.5 divided by here. So again, you have got your I1 and I2. So that was 2.5 and 2.5 ampere. So that was one way, by simply applying the voltage division. But again, in the case where if the resistance of both the circuits would not have been equal, so you have got VR1, so you can substitute it here. So it will become minus 100 plus 500 volt plus I1 into, R is your R1, so it is 20, so equal to 0. So you are getting, if I'm putting this, solving this equation here, so you are getting a 400 volt plus I1 into 20 equal to 0. So my I1 is simply 400 divided by 20. So there's some mistake here, which is my I1 R1 IR1 is plus I1, which is into 20. So this is not 200, 500. What is this? I R1 is, my I is 5 and my R1 is, so this is 50. So my I is 5 ampere and this is 10, so this is 50. So what I'm getting here is minus 100 plus 50 plus I1 into 20 equal to 0. So that is equal to something like minus 50 equal to divided by 20 equal to minus I1. So my I1 equal to 2.5, which is same which I got by applying the current division for the parallel resistance were same. So again, whatever I have solved for this circuit is correctly validated, and even if you are having these two resistance different, it is very much simple to find. So this was another problem in which I applied the KVL, I applied the KCL, and the question was to find the current I1, I2 in the branches for the resistance R1, R2, and again I found the total current I of the circuit. So this is how you can apply the different rules like KCL, KVL and series parallel solution, also Ohm's law, to solve the problems of electrical circuits. So what we saw in this lecture was, we saw about Ohm's law, we saw about the KVL, we saw about the KCL, we saw the power equation for the electrical circuit, which is VI or I square R. Find the power consumed or power lost in the circuit. So again, you found out how to solve the series circuit. So if there is a two resistance in series R1, R2, then the R equivalent can be written as R1 plus R2, and if there is two circuit in parallel, then the R1, R2 is there, then the R equivalent will be coming from 1 upon R1 plus 1 upon R2 solution. And again, all the problems have been formulated by me myself. So you'll not find the same problem anywhere else. And again, if you have some kind of a problem which you want to solve, you can always comment at comment them, so that if I get time I could make a video or solution in future for those problems.